Hey everybody, in this video we'll explore the three laws which form Kepler's laws of planetary motion. The three laws can be described as follows. The first law, this is a law of ellipsis. The path of the planets about the Sun is elliptical in shape, with the center of the Sun being located at one focus. The focus is here because the center of mass heavily lies at the Sun. The second law, the law of equal areas. If an imaginary line is drawn from the center of the Sun to the center of a planet, then the planet will sweep out equal areas in its orbit in equal intervals of time. This means a planet moves faster when it is closer to the Sun, while it moves slower when it is further from the Sun. So the law of having equal areas is covered in both. And the third law, the law of harmonies. The ratio of the squares of the periods of any two planets is equal to the ratio of the cubes of their average distances from the Sun. This means the square of the period of a planet's orbit is proportional to the cube of the average radius of its orbit. To derive Kepler's third law in mathematical terms, we need to first recognize G equals 4 pi squared L divided by T squared, shown in Newton's pendulum experiment. We know that the length of the string in the pendulum experiment is the same as radius, therefore we can now write it as G equals 4 pi squared R divided by T squared. Also recognize G is equal to capital G M divided by R squared. The G here is on a celestial body. Now we equate both. Therefore, we get this relationship when we equate both to each other. Next, move the period and radius to the left-hand side, that is, make them the subject, and everything else to the right-hand side. This gives us T squared divided by R cubed, which is equal to 4 pi squared divided by capital G M, which is known as Kepler's third law. An important assumption for the third law is objects must orbit the same central mass, such as the same Sun. Let's now apply our knowledge learned on this topic to a practice example. So, the example we have today is the planet Mercury travels around the Sun with a mean orbital radius of 5.8 times 10 to the power of 10 meters. The mass of the Sun is 1.99 times 10 to the power of 30 kilograms. Use Kepler's third law to determine how long it takes Mercury to orbit the Sun. Give your answer in Earth days. Therefore, when completing this question, the following working out should be obtained. So we were given the following data, where the radius of the orbit of Mercury around the Sun is 5.81 times 10 to the power of 10 meters. The mass of the Sun is 1.99 times 10 to the power of 30 kilograms. And we need to determine the period of Mercury. So we write Kepler's third law down, rearranged for T as the subject, which is period. Then we substitute in the relevant data, so 4 pi squared gives us 39.5. G is a gravitational constant, so 6.673 times 10 to the negative 11. M is the mass of the Sun from the question, and that is multiplied by radius cubed, where radius in this case is the orbital radius of Mercury, given as 5.81 times 10 to the power of 10. Then we perform some algebra and simplify this down to this after a set of steps of mathematics. And then we get 7.63 times 10 to the power of 6 seconds. However, the question did specify the answer needs to be in days, so we convert it into days, performing the following calculations here, and hence we get 88.3 days as the period, which is the answer. I hope this video on Kepler's laws of planetary motion was useful in building your understanding of this topic. Thanks for watching. See you later.